How does a car suspension work? The car suspension absorbs vibration, gravitation, and impact forces from the road. It ensures the car stays in contact with the road surface. When a tire hits an obstruction on the road, it experiences a reaction force that depends on the unsprung mass at each wheel assembly. The sprung mass includes the part of the car supported by the springs, such as the engine, car body, the frame, and other associated parts. Unsprung mass is the part of the steering and suspension not supported by the springs, like wheels, tires and brake assemblies. A car suspension system reduces the impact forces from the road by always keeping the tires in contact with the road surface, which also helps to minimize rolling and flipping over. Car suspension components. The suspension system is comprised of several components, such as the steering knuckle, damper, spring, control arm and tires. The two principal components of a suspension system are the springs and dampers. Spring is the energy storage unit. The spring enables the car to compensate for any irregularity on the road surface, and keeps car suspension at a predetermined height. There are 4 types of springs currently used in car suspension systems: coil spring, leaf spring, torsion bar and air spring. Coil springs. This is the most common type of spring. A coil spring is simply a spiral of resilient steel rod. They compress and expand to absorb the motion of the wheels. The leaf spring is a basic form of suspension, which is made up of steel layers of different sizes, sandwiched on top of another. The steel is usually cut into rectangular sections, and then secured once with metal clamps. The leaf spring is fixed to the axle housing by a large U-shaped bolt. Rubber bushings are used on the front and rear to reduce the impact from the road. A damper is also fixed in a clamp to dissipate the stored energy from the spring. The end of the leaf spring is directly connected to the frame by a shackle. Leaf springs are used today mostly on trucks and heavy-duty vehicles because of its simplicity. The torsion bar is a length of metal rod, anchored at one end to the car frame, and at the other end to the suspension lower link, or a wishbone. When the wheel hits a road bump, vertical motion is transferred to the lower link, and then through the levering action, to the torsion bar. The torsion bar will then twist along its axis, to provide coil spring-like performance. Air spring is used in place of conventional coil springs. Air springs contain a column of air in an elastomeric bellow, or sleeve, and use the compressive abilities of air to absorb vibrations and shocks. Springs are energy storage units. They are good at absorbing, but not dissipating the energy. A smooth ride requires both springs and the dampers. A spring help absorbs the energy off bumps on the road, and a dampening mechanism helps control and dissipate the energy up and down. Shock absorber is a device that helps to control the unwanted spring motion through a process called dampening. For the shock absorber, one end is connected to the body or frame, and the other is connected to the axle or control arm. There are different types of shock absorbers, but they all use a piston sliding in a cylinder filled with hydraulic oil. The kinetic energy of suspension movement transforms into heat energy that can be dissipated through hydraulic fluid. The suspension strut is basically a shock absorber mounted inside a coil spring. The bottom of the strut is attached to the steering knuckle, and the top of the strut is connected to the car body via an upper strut mount. Anti-sway bar is also called an anti-roll bar. Anti-sway bars are metal rods which span the entire axle and work to join the opposing suspension systems on the same axle. Anti-sway bars combined with shock absorbers, or suspension struts, provide the car with additional stability. When there is motion in one side of the wheel, this motion will be transferred by the anti-sway bar to the other wheel, to create a more level ride. Before we look at how suspensions provide control, and the different types of suspension, we firstly need to study the wheel alignment, and how it would help a car suspension system. Wheel alignment is basically to measure and adjust several complex suspension angles, including camber, caster, and toe angle. What is camber? Camber is a measure of the tire's centerline relative to the road surface. It is measured in degrees, and has a great influence on the driving dynamics of the car. Negative camber, the top of the tire tucks inwards. Positive camber, the base of the tire tucks inwards. Positive camber combined with steering axis inclination could be adopted to reduce steering effort and minimize tire wear. What is steering axis inclination? The steering axis inclination is the angle between the centerline of the steering axis and the vertical line from the tire contact surface in a front view. The distance between the steering axis and the center of the contact patch is the scrub radius. By combining the steering axis inclination and positive camber, the tire has a smaller scrub radius, thus has less steering effort and tire wear. Negative camber improves handling by keeping better contact of the tire with road while the car rolls. As the car rolls, it puts most of the weight on the outer tire, therefore it's better to have negative camber on the outer tire to ensure the tire's contact patch is evenly loaded. What is caster? Caster is the angular displacement of the steering axis from the vertical axis of the wheel, viewed from the side. Positive caster is when the wheel is in front of the upper pivot point. Negative caster does the opposite. Modern vehicles use positive caster, which generates an aligned torque to help straighten the steering wheel when the car goes forward. What is toe? Toe is the direction the tires are pointed, relative to the vehicle centerline, viewed from above. Toe in, tires point inward, the angle is positive. Toe out, tires point outward, the angle is negative. Toe in is typically applied in a rear-wheel drive car. A rear-wheel drive car pushes the front tires. This causes the tires to push back with respect to the suspension. Therefore, rear-wheel drive vehicles use toe-in adjustments to compensate for this movement. A front-wheel drive car does the opposite. The front tire pulls the car. The weight of the car body resists forward movement. This pulls the front wheels forward with respect to the suspension. Therefore, front-wheel drive vehicles use toe-out adjustments to compensate for movement. For more information on the camber, caster and toe, please see our video on wheel alignment, on the right corner. The four wheels of the car work together in two independent systems, the front suspension and the rear suspension. A car can have different types of suspension on the front and rear. If the wheels are allowed to move independent of each other, it is an independent suspension. If the two wheels are connected by a rigid axle, it is called a dependent suspension, such as a solid axle leaf spring suspension. Here we'll look at some common types of front and rear suspensions. McPherson strut suspension. The McPherson strut is the most widely used front independent suspension system, that the wheels are allowed to move independently. A McPherson strut suspension combines two major functions. As a steering rod. As a suspension dampener. Basic McPherson strut design. Let's look at the major parts of a McPherson strut suspension. A single control arm connected to the bottom of the wheel hub. A shock spring combination protruding from the top. The McPherson strut combines the coil spring and shock absorber into an integrated unit. This gives a more compact and lighter suspension framework that can be used for front-wheel drive vehicles. A steering link connected to the wheel hub. The simplicity of the McPherson strut suspension is its major advantage. The McPherson strut suspension effectively combines spring, strength and stability and low manufacturing cost. Without the need for a separate upper control arm, the McPherson strut requires less components to produce, which is cheaper to make, more lightweight, and smaller than other suspension systems. McPherson strut suspension is great for front-wheel drive, since the space it allows for the drive shaft. There is nothing in the center, so it can easily accommodate a drive shaft there. The McPherson strut suspension has a lengthy vertical assembly, which would run into problems if needed to lower the vehicle, thus it's not suitable for a race car or sports car, as these types of vehicles are often lowered closer to the ground. Due to the simplicity of the McPherson strut suspension, it is small camber changes with body roll. Because the strut is moving linearly, the wheel gains camber to a certain extent, and after that will start to lose camber. This could hamper a car's handling, and experience a lot of body roll and cornering. This makes the McPherson strut more inferior to other advanced suspension systems, such as the double wishbone suspension. Double wishbone suspension. The basic design. Double wishbone suspension is an independent suspension system. It allows each wheel to act independently from the others. This is accomplished by two wishbone-shaped arms, also called double A arms, that are located between the steering knuckle and the chassis. The upper and lower control arms have ball joints at both ends, to enable movement in all directions. Each wishbone or arm has two attachment points on the chassis, and one joint at the steering knuckle. Vertical motion is controlled via the coil spring and shock absorber mounted on the wishbones. The spring and damper could be attached to the upper control arms, and to the chassis. A more popular configuration is attached to the lower of the two A-arms, as the system is much more compact. As a more complex design, the double wishbone allows for better control over camber and body roll. Traditional double wishbone suspension is made up of two parallel control arms of equal length. The advantage of this is that, as the tire has a positive or negative vertical motion, the tire travels in a straight line, and the camber angle stays the same. The disadvantage is when the car goes around a corner, that camber angle changes as the car body rolls. Let's look at the camber when the car goes around a corner. In this case the car is going around a right corner, and the car body is going to roll to the left. For a double wishbone suspension with equal length control arms, the car will have slight positive camber on the outside tire, and negative camber on the inner tire. This is not a desirable design, as the outer tire is taking most of the load, while the inner tire is taking less load. To solve this problem, the double wishbone suspension uses a shorter upper control arm, that the tire will have induced negative camber during a vertical travel. This is beneficial when the car goes around the corner. Due to the shorter upper control arms, the car will have slight negative camber on the outside, so the outer tire goes flat with the road surface. This is where the car wants to maintain the maximum amount of contact. The inner tire will have a slight positive camber. It is pressing flat against the road. The more a double wishbone suspension is compressed, the more negative camber is gained, due to the use of unequal length control arms. As the car is cornering and starts to roll, a double wishbone suspension system ensures better contact of the tires with the road. A double wishbone suspension has more components, and therefore it is more expensive to design, manufacture, and maintain than other suspensions. In addition, due to the large number of parts, a double wishbone suspension system is heavier, and requires more space than other suspension systems. Multi-link suspension. Derived from a double wishbone suspension, the multi-link suspension has 3 or more lateral arms, plus 1 or more longitudinal arms. The arms do not have to be of the same length. In addition, they can be angled away from their natural orientation. Each arm usually has a ball joint or rubber bushes at each end. Some multi-links use wishbones with 2 bushings on one end. Some multi-links also use trailing arms. A variation of the same concept is the solid axle multi-link system. The solid axle multi-link system offers similar benefits, but has several advantages over independent multi-link suspensions. It is much cheaper and easier to build, offers good mechanical durability, and excellent reliability, and has very similar advantages. The solid axle multi-link suspension uses the lower and upper arm, to control back and forth movement and rotation. This rotation occurs during acceleration and braking. Multi-link suspension is considered to be the best independent system for production vehicles, as it offers the best compromise between space efficiency and handling, as well as comfort and handling. In the simplest form, the multi-link suspension is orthogonal, that it is possible to change one parameter at a time within the suspension, without affecting the entire assembly. Despite all the advantages, multi-link systems are expensive, and complex to design and manufacture. In addition, it is difficult to tune the multi-link geometry, without a complete 3D computer-aided design analysis. Trailing arm suspension. Trailing arm suspension uses a trailing arm, which extends forward to a pivot on the car body. The upper part of the trailing arm supports the coil spring. Trailing arm suspension can be found in rear-wheel drive passenger cars, and light trucks. The advantage of a trailing arm suspension is that it allows both rear wheels to move independently. However, a trailing arm suspension only allows the wheel to move up and down on road bumps. The design does not accommodate any lateral movement or camber change relative to the car body. When the vehicle rolls into a corner, the trailing arm rolls by the same amount as the car body, changing the camber angle relative to the road surface. The arm is rigidly attached to the wheel at the other end, thus shock and noise can inevitably be transmitted to the car body, especially during cornering or driving on bumpy roads. We will look at later how the trailing arm design could be improved with a torsion beam. Common rear suspensions. A car rear suspension system has greater latitude in its design. Unlike a front suspension, it doesn't need to take into account the steering mechanism. It is common for many cars to use dependent systems for the rear axle. There are two major types of dependent rear suspension: the solid axle commonly used on rear-wheel drive cars, and the beam axle used on front-wheel drive cars. The leaf spring suspension. How the leaf spring works. Most leaf springs are made in an elliptical shape using spring steel, which has the properties of allowing it to bend when pressure is applied at both ends, and then return to its original position through a damping process. The elasticity of the spring steel makes the suspension flexible, which can provide comfort and control when the car is driving. For decades, the leaf spring has proven to be a viable suspension system. It is common for many cars to use leaf springs as a dependent rear suspension. Compared to coil springs and shock absorbers, leaf springs are simple in design and have low production cost. Mono-leaf spring is the simplest design, using only one leaf of spring, also called a parabolic leaf spring, that tapers from the middle thickness to the edge, to properly distribute the vertical load. Due to the large number of metal layers put together, the leaf springs provide great support between the wheels, axles and chassis of the car. Because of their tight-knit structure, they can withstand the huge vertical loads imposed on them, which is why they are still used in heavy industries. The big downside of leaf setups is that they are not brilliant when it comes to adjusting the suspension. The leaf setups also allow few directions of motion, and are only really designed for vertical movement, while the coil spring and damper combination can be manipulated over a wider range of motion. The leaf springs are firmly clamped together and bolted to the chassis, as there is almost no room for any other direction of movement. This can cause severe wear on the joints and connections that hold the setup together. The same basic design can be achieved by replacing the leaf springs with coil springs. The coil spring and shock absorber can be mounted as separate components or as a single unit. Unlike the leaf spring suspension for load-carrying vehicles, a solid axle coil spring suspension has reduced unsprung weight and less stiff springs, that it is also well suited to passenger cars. Torsion beam suspension. Torsion beam suspensions, also known as twist beam suspensions, are commonly found on some entry-level or cheaper car models, due to their low manufacturing costs. A torsion beam suspension bases on its design from a trailing arm suspension. Torsion beam suspension improves the design by joining the two trailing arms together by a cross member. The cross member itself acts as an anti-roll bar. When a wheel hits a bump and goes up, the beam will be deflected, and transfer part of the load into the other wheel. It will produce a torque along the beam to force the other side to go up as well. A torsion beam suspension provides the wheels a certain degree of independence, but not fully independent, as they are still linked by the beam. Compared to other types of suspensions, a twist beam suspension is simple in design and is cheaper to make. The beam itself acts as an anti-roll bar that simplifies things at the rear. However, it doesn't allow for much wheel adjustment by engineers. It also needs a lot of reinforcement to mitigate the fatigue at the welding points. Nowadays, new types of car suspensions are also gaining popularity, such as the air suspension, which uses air bellows to replace the conventional coils and dampers. The airbag is filled with air from the tank to keep the car at the desired height. To lower the car, air is released from the airbags. To lift the car back up, pressurized air is pumped back into the suspension. Air suspensions provide great comfort and load-bearing capacity. that air suspensions are currently used in some luxury and sports cars, as well as on many trucks and buses.